Okay, statistics students, I have a challenge for you. I sent this to you. This is the filled in sheet from the Powerball stuff. Some of you guys didn't get this quite right. When you do Powerball, you cannot repeat a number, so that's important when you calculate the probabilities. If you can repeat a number, the odds are even worse, actually. So you do pick one out of 5 numbers from 1 to 69, but they're 5 different numbers. And it wasn't, the page I see isn't very clear, but you have to read it carefully. And then, so you cannot repeat a number, and you pick 5 from 1 to 69, and then the Powerball is 1 to 26. And then that's $2 to do that, which doesn't sound like a lot. Then they say, oh, you can pay an extra $1 to do this multiplier, and the multiplier is chosen at random, supposedly, before the lottery is drawn. So you don't know in advance what the multiplier will be. And it's a way for them to get it. $1 doesn't sound like a lot of money, so they're getting you to spend that extra $1. Most people, that's just money down the drain. And it's really 50% more than the cost to play. So that actually puts a lot more money in the lottery people's pockets. So, and here are the odds. These were at the bottom of the Powerball. There's a link you could click to see these odds of the 9 ways to win. So there you go. What I want to show you today is how these odds are calculated. It's a little complicated, but I do want to show it to you. And I'm going to challenge you to calculate one of the other ones, figure out back into how did they get these odds on one of the other ones. So I'm going to calculate the odds that you match 3 white balls and no Powerball. So let's get started here. So we're going to calculate the odds of winning with 3 white balls matching. According to the website, these odds are 1 out of 579.76, approximately. This is probably a decimal that goes on forever. We're going to see if we can get close to this number. And on any draw, there are 5. So I want you to think about things this way. On any draw, there are 5 winning white balls. That should say white. That leaves 64 losing white balls. So if that was 64, I get by taking 69 minus 5. There were 5 numbers that were the winning numbers. That means there are 64 losing numbers. That's important when you're thinking about odds. For the red Powerball, there's only one red Powerball that is chosen. One of them is the winning ball on any given round, and 25 are losing balls. So, actually yes, that's right. Okay, so first we're going to think about the probability as a denominator being all the possible outcomes and the numerator just the possible outcomes for the type of win that we're interested in. So I'm going to do the denominator first. It's simpler, and the denominator is the same for all of the probabilities because the bottom of a probability represents all possible ways of arranging the outcomes. So we're going to start with the denominator, and when you guys try and do this on a different one, your denominator will always be what I'm writing down here. It's all the ways to pick 5 white balls and 1 Powerball. We don't care about which ones are the winning. We're just saying all the ways to have 5 different numbers picked from 1 to 69 and 1 Powerball from 1 to 26. So this is the way you want to think about it. When you pick the first one, there are 69 choices. We don't care about whether it's a winning one or a losing one. There's 69 choices. So that 69 represents all the possible first choices. Then once you've chosen one, since you can't repeat, there are 68 choices for your second choice that you made for the white balls, and then 67 for the third choice, 66 for the fourth choice, and 65 for the 5th choice. And then when you get to the 6th ball, which is the red Powerball, that's a whole different set of numbers. There's 26 choices for that. And you can repeat, by the way, a Powerball can be any of the numbers you can repeat a Powerball. So that's its own sort of basket of balls, kind of. But you think of these 5 as being one basket of balls, and you chose 5 of them. So every time you take a ball, there's one less ball in the basket, and that means you only have 68 choices for choice 2, and so on. You might say, well, that's it. But the problem is this doesn't take into account that picking, say, the numbers 1, 3, 8, 9, and 10 is the same. Like, let's say you picked 1, 3, 8, 9, and 10, what I just said, in that order. Well, I could have just reversed the order of the first 2 and said someone else said, well, I picked 3, 1, 8, 9, 10. That's actually the same outcome from the Powerball standpoint because they don't care the order you pick your numbers. They always report them in numerical order, but you could have pick them in any order, and therefore these are the same outcome, but you don't want to count this twice. So the way to undo all the different combinations of a certain set of 5 numbers is to divide by 5 factorial. That takes care of not double counting things like this. So the 5 is because if you want to find all the ways to arrange 5 numbers, the same 5 numbers, that actually is 5 factorial, which is 5 times 4 times 3 times 2 times 1. That's the same factorial we did when we did binomial stuff. So that's your denominator of your probabilities. The numerator for ours is, I'm going to show you how to think about it. And we're looking for 3 white balls matching and nothing else matching. So from the white balls, I am saying I'm going to first think about the 3 winning balls. I only have 5 winning balls, but I have 5 ways to pick one of the winning balls for my first pick. And then once one of the winning balls has been picked, I only have 4 ways to pick the second winning ball because we've already picked one of them. And then, now of course you don't know this in advance, this is just for calculating the number of ways you could actually pick the winning combo with 3 white balls and nothing else matching. And then there's 3 ways to pick the third winning ball. Okay, now the other 2 winning balls we didn't pick, so we aren't going to count those in our numerator. But then you have 5 white balls. This is the 3, this is assuming you picked 3 winning white balls. There were 5 ways to pick the first, 5 sort of chances to pick the first one right, then 4, then 3. Then the 4th and 5th ball that we have in our combination are not winning balls. And we said there are 64 losing balls. So there were 64 ways I could have chosen one of the losing balls. And then there were if I did choose one of the losing balls, there were 63 ways to choose a second losing ball. So this represents the number of ways to pick 3 winning balls and 2 losing balls. But just like this, I have to divide by 5 factorial, well, not 5 factorial, I'll tell you what in a minute. I have to worry about rearranging these numbers. By the way, and then we want to have we are not picking the winning winning power ball, so we have 25 ways to choose the wrong power ball. So that has to be multiplied into. Now this is its own standalone thing, so it's either 1 or 25, and there's no rearranging it. Either you got it or you didn't. But these, if these 3 were the winning balls, I could have picked them in any order. So you have to divide out 3 factorial to take care of the different ways to order 3 balls that are really the same outcome. And then the 2 losing balls in the white pool, I also have to divide out the ways to rearrange those, because let's say number 21 was a losing number and number 25 was a losing number, and I chose both of them. But I could have chosen it as 21-25 or 25-21. That's 2 ways to arrange them, so that 2 factorial takes care of the different ways to rearrange 2 losing balls in terms of the order. So this is my numerator for this problem. So this is the 5 white balls, because this represents 3 winning that I chose, one from, one over and over, but the number of possible ways to get a winning ball goes down every time you manage to get a winning ball. And then these are my losing. Now let's do the calculation. So the probability of 3 white balls matching, exactly 3 white balls matching, is, my numerator is 5 times 4 times 3 times 64 times 63 times 25 over 3 factorial times 2 factorial, all over my denominator, which is 69 times 68 times 67 times 66 times 65 times 26, all over 5 factorial. You're probably saying, Mrs. Culp, why are you doing this? I just find this interesting, and this is how the odds are done. That's a nasty fraction. I'm going to rewrite this not as a complex fraction. So it's 5 times 4 times 3 times 64 times 63 times 25, all over 3 factorial times 2 factorial times, and then I'm going to flip the bottom fraction, because dividing by a fraction is the same as multiplying by its reciprocal. So I get this. Oops. And let's think about what 5 factorial, we get a little reducing here, and then I'm going to use my calculator. 5 factorial is 5 times 4 times, I'm going to go into another sheet of paper. I have 5 times 4 times 3 times 64 times 63 times 25. 3 factorial is 3 times 2 times 1 times 2 times 1. That's this. 5 factorial is 5 times 4 times 3 times 2 times 1. All over my denominator, which is 69 times 68 times 67 times 66 times 65 times 26. But a lot reduces here. This 3 goes with this 3. The 4 goes with both 2. So this is really just 10 in the top. Now I'm going to go to my calculator and calculate this. And I left my calculator over there. I'm going to get it and show you. So I'm going to put this in the calculator, right, that this does equal the odds we're interested in. So let's go. It's 5 times 4 times 3 times 64 times 63 times 25 times 5 times 2. That's what's left here, right? Divided by, there's nothing here, that's just 1. I'm going to need parentheses, because if you don't put parentheses for a denominator, you're going to only divide the first number. 69 times 68, whoops, I think I made a mistake here. I have an extra 68. Times 67 times 66 times 65 times 26. Close my parentheses, hit enter. I get 0.001724 and so on, right? Now, they told us the odds were 1 out of, the website said it was 1 out of 579.76. I'm going to turn that into a decimal and see if they're equal. 1 divided by 579.76. Don't forget this is an approximation because they really would have been a long decimal number. Where's my equal? Whoops, I did 1 times. 1 divided by 579.76 equals, oh look, it's the same. The only reason it's different out in these lower decimal numbers is because the website one is, this is a rounded version of the real odds. But what this shows me is I'm confident that I did it the right way because I'm so close. And mine's actually the more exact one. But the website isn't going to give you this long decimal number. So my challenge to you guys is to pick a different one and see if you can back into the odds the way I did. I know this may seem hard, but this is real world probability. Your denominator is always going to be this, okay, what I wrote here, and this is your denominator flipped. This is the part you have to come up with. And this last slot's either going to be 1 or 25, depending on whether you got the Powerball or not. If you got the Powerball, this is a 1. There's only one way to get the Powerball, right? If you're calculating the odds of one where you did not get the Powerball, then this is going to be a 25. These 5 numbers are a different combination of how many white balls you got right and how many white balls you got wrong. For the white balls you got right, you're drawing from 5, 4, 3, 2, and so on. For the white balls you got wrong, you're starting with 64 choices, then 63, and so on until the number you got wrong. Then you have to divide by all the ways to rearrange the right and wrong balls. Then do the math on this big calculation and see if you get close. What I'd like you to send me by Monday is one that you think you cracked or got as close as you could, and I'm just interested to see what you guys come up with. You can work with each other on this. Thanks.